One thing you have to know about me. I can love you more than anyone in this world. I can even understand you when you're not in good moods. But once I feel that my presence doesn't matter in your life anymore, I'll disappear so easily.
In traditional Newtonian and relativistic physics, the universe is treated as a chronological sequence of events. This leads to the inevitable and circular first cause paradox. If everything has a cause, what caused the beginning? Within the quantum physics theory, QPT, this paradox is resolved by identifying two fundamental errors in classical thought: the personification of energy and the reification of time. 1. Time as a measurement, not a dimension. The question, who created God, energy, requires a before. However, as established in this model, time is a man-made mechanical measurement used to track the movement of matter. It is not a physical fabric that exists independently of the grid. In a universe where time is not a physical thing, the concept of a beginning is a human biological projection. The kinetic grid does not exist in time. Rather, time is what we call the observation of the grid's internal vibrations. 2. The perpetual pressure. Gradient. The origin of energy is not a historical event, but a structural necessity. In the 2:1 space-expanse ratio, existence is defined by a constant state of pressure.
So Kawecki resolves the conflicts, or as he sometimes calls them, the indifferences, between local planetary fields and the ever-expanding cosmic space by introducing his concept of variable warp density fields. Matter is condensed warp density. In Kawecki's theory, what we perceive as objective matter, like a planet or a star, isn't really a distinct entity at all. It's actually just a highly localized, extreme concentration, or you could say, a knot of this fundamental energetic warp density. This is basically his version of E equals mc squared. Matter is simply condensed space-time energy. Gravity, in this view, is the play of density fields. The so-called force of gravity doesn't come from the curvature of some objective geometric fabric. Instead, it's just the natural interaction, or the play, between these different density fields. A high-density field, like a planet, naturally creates a gravity well in the surrounding, lower-density field. The expansion of the universe, often referred to as Hubble's universe, can actually be seen as the massive general low-density field of the cosmos trying to equalize, or, relax from that initial high-energy distortion caused by the Big Bang. Not at all objective, the flexible nature of reality. This honestly is the most critical part of your question when we look at Kawecki's work. Subjective spacetime. While standard physics tends to see spacetime as having, an absolute structure, even if it's curved, Kawecki argues something quite different. He suggests that because spacetime is actually an energetic density field, it's fundamentally flexible and, in a sense, subjective. Suspending mainstream laws. Kawecki contends that in the extremely low-density zero-point microgravity space fields that make up most of the universe, the typical objective laws of relativity, especially those equations that would predict infinite mass, just don't apply. And really, this flexible nature is what he claims would mathematically allow for faster-than-light space travel within a moving vessel, sidestepping the restrictions of Einstein's objective reality.